Welcome to our comprehensive guide on unit testing interview questions. Unit testing is a fundamental practice in software development where individual components or modules are tested in isolation. Today, we'll explore the core concepts that every developer should master, including test isolation, mocking and coverage, dependencies management, and automated testing practices. These concepts form the foundation of effective unit testing and are frequently asked about in technical interviews. Unit testing is the practice of testing individual components or modules in isolation to ensure they work correctly. The key emphasis here is on isolation. Each unit test should focus on a single piece of functionality without depending on external systems or other components. The primary benefits of unit testing include fast execution times, early bug detection during development, and improved confidence in code changes. Unlike integration tests that test multiple components together, unit tests are designed to be lightweight and execute quickly, making them ideal for continuous development workflows. Every effective unit test follows a clear structure known as the Arrange-Act-Assert pattern. First, we arrange our test data and set up the necessary preconditions. In this example, we set variables a and b to 5 and 3 respectively. Next, we act by executing the code under test. Here we perform the addition operation. Finally, we assert the expected outcome using an assertion statement that verifies the result equals 8. This three-step pattern makes tests readable, maintainable, and easy to understand for other developers. Test isolation is crucial for reliable unit testing. Independent tests mean each test should run independently without depending on other tests or shared state. When tests depend on each other, a failure in one test can cause cascading failures in others, making it difficult to identify the root cause. Clean environment practices ensure that tests set up and tear down their own data and dependencies. This means each test starts with a fresh environment, eliminating side effects and ensuring consistent results regardless of test execution order. Mocking is essential when testing code that depends on external services, databases, or other components. Test doubles like mocks replace real dependencies with controlled substitutes. In this example, we use the unittest.mock library to mock an HTTP request. The patch decorator replaces the real requests.get function with a mock object. We configure the mock to return a status code of 200, then verify our function handles the response correctly. The assert called once method ensures our code actually called the mocked function, validating the interaction occurred as expected. Assertions are the heart of unit testing. They verify expected outcomes and cause tests to fail when conditions are not met. Basic assertions include assert, assert equal, and assert true, but modern testing frameworks provide many specialized assertion methods. Best practices recommend using specific assertions with clear error messages for better debugging. Instead of generic assert statements, use methods like assert raises for exception testing, assert in for membership testing, and assert is none for null checks. Specific assertions provide more informative error messages when tests fail. Test coverage measures how much of your code is executed during testing. The coverage tool is a popular Python library for measuring code coverage. To use it, first install coverage using pip install coverage. Run your tests with coverage run -m pytest tests / to collect coverage data. Generate a text report with coverage report -m to see which lines are covered. For detailed analysis, use coverage HTML to create an interactive HTML report showing exactly which code paths are tested and which are missing coverage. Automated testing practices integrate unit tests into your development workflow through continuous integration and continuous deployment pipelines. Popular CI/CD platforms like GitHub Actions, Jenkins, and GitLab CI can run tests automatically on code commits and pull requests. This automation provides fast feedback loops, immediately notifying developers when changes break existing functionality. Test automation ensures consistent test execution across different environments and prevents manual testing oversights. The goal is to catch issues early in the development process when they are cheaper and easier to fix. Setup and teardown methods are commonly asked about in interviews. The setup method runs before each test method, allowing you to initialize test data and configure the test environment. In this example, setup creates a dictionary with test user data that each test can use. The teardown method runs after each test completes, providing an opportunity to clean up resources like closing database connections or deleting temporary files. This pattern ensures each test starts with a clean state and properly releases resources, preventing test interference and resource leaks. To excel in unit testing interviews, remember these key principles. Always isolate your tests by avoiding dependencies between test cases and using proper mocking for external services. Maintain good test coverage, but focus on quality over quantity. Meaningful tests are more valuable than high coverage percentages. Practice writing tests for edge cases and boundary conditions, as these often reveal the most bugs. Embrace test-driven development practices where you write tests before implementing functionality. Master these concepts and practice explaining your testing approach clearly to succeed in technical interviews.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.